I want you to picture a museum. But this isn't, some building in Paris or New York.
Right, it's a bit further away.
Yeah, it's an open-air museum sitting exactly 238,000 miles away from where you are right now.
Up on the moon.
Exactly. And in this museum, there are 6 American flags. But they aren't red, white, and blue anymore.
No, they've been completely bleached white by decades of just unfiltered sunlight.
Yeah, the fabric is totally stiff, baked by these heat cycles that would melt lead, and then frozen by cold that would turn oxygen solid.
It's a pretty intense environment.
It really is. And just beneath those flags are footprints. Perfect, undisturbed footprints pressed into the dust between 1969 and 1972.
And they're perfectly preserved because, there's absolutely no wind to blow them away.
Right. It's this hauntingly still image.
Yeah, for over 50 years, the moon has essentially been trapped in amber, like this finished chapter of Cold War history.
But, and this is why we're here today, that quiet era is officially over.
Completely over.
Today, we're jumping into a new deep dive, cracking open a stack of research, everything from intelligence reports to engineering roadmaps.
Oh yeah, a lot of material.
Right, and it's all centered around this comprehensive analytical guide called Race to the Moon: Science, Sovereignty, and the Second Age of Lunar Exploration.
Which is a fascinating read, by the way.
It really is. So our mission for you today is to pull back the curtain on why, as we sit here in mid-2026, this airless museum is rapidly transforming.
Transforming into what is basically the most consequential, heavily contested, and crowded piece of infrastructure of the 21st century.
Yeah, it's wild. But we have to drop the nostalgia immediately, right?
Absolutely.
Yeah.
The hardware being rolled out to launch pads right now, it is not a rerun of 1969 with, upgraded 4K cameras.
Right.
We are watching an entirely new race. And it's driven by physical resources and geopolitical positioning, not just symbolic flags.
And the most alarming part.
Well, yeah, the most alarming part is that this new race is happening with almost zero enforceable rules of engagement.
Which is exactly why you need to care about this. You aren't just witnessing history repeat itself in high definition.
No, you are watching the actual blueprint for humanity's off-world economy being drafted in real time.
Exactly. The technologies and supply chains being tested right now, they will dictate international commerce, energy markets, and global security for decades.
It's huge. But to truly grasp why the world's superpowers are suddenly sprinting back to the moon in 2026, we sort of have to understand the mechanics of why we stopped in the first place.
Right, why we abruptly slammed the brakes 54 years ago.
Right, so the psychological engine of that first space race was pure, unadulterated fear.
Driven by the Cold War.
Exactly. The entire endeavor stemmed from this terrifying realization at the end of the Second World War. Basically, rocketry and weaponry are identical twins.
Oh, wow. Yeah, when you think about it.
Right. The US and the Soviets were scrambling to capture German V-2 rocket engineers, like Wernher von Braun, because the fundamental physics are identical.
The same thrust and guidance tech required to escape Earth's gravity is the exact same tech required to, drop high explosives across a continent.
Precisely. And that fear totally crystallized in 1957.
When the Soviets launched Sputnik 1.
Yeah. For anyone alive back then, that realization was just visceral.
Sputnik was just a metal sphere, right? The size of a beach ball, just beeping away in low Earth orbit.
But the logic it presented to the United States was inescapable. If the Soviet Union can put a metal ball over American airspace,
they can put a nuclear warhead over American airspace.
Exactly. So the Sputnik crisis triggers this massive mobilization. But the Soviets just kept widening that lead. In 1959, their Lunar II probe literally smashed into the moon.
The first human-made object to do that.
Right. And then by April 1961, Yuri Gagarin is orbiting the Earth.
Which brings us to John F. Kennedy. He's newly inaugurated, and this isn't just a loss of scientific prestige for him.
No, it was an unacceptable signal of ideological weakness to the rest of the globe.
Right. And that leads to JFK's legendary 1962 speech at Rice University. You know, the one, "We choose to go to the moon, not because they are easy, but because they are hard."
It's incredible, soaring rhetoric.
It really is. But underneath that poetry, it was a totally ruthless geopolitical calculation, wasn't it?
Oh, 100%. Kennedy needed a finish line. He needed a goal that was so outrageously difficult and far away that the Soviets' current head start wouldn't even matter.
Right, but specific enough that the world would know exactly who crossed it first.
Exactly. And, the cost of building that finish line was just staggering.
Oh, yeah. NASA eating up, what, 4% of the entire U.S. federal budget at its peak?
Yeah, just to make the Saturn V rocket a reality.
Yeah.
The engineering required to control millions of pounds of explosive thrust was unprecedented.
And the human cost was horrific, too.
It was. We lost Gus Grissom, Ed White, and Roger Chaffee in the Apollo 1 cabin fire in 1967.
But the momentum was just unstoppable at that point.
Right, leading to Apollo 11 in July 1969. An estimated 600 million people watched Neil Armstrong step off that ladder.
1 out of every 6 human beings on the planet watched it live. That's insane.
It really is.
And we did have 5 more landings after that, and of course the Apollo 13 near catastrophe with the oxygen tank.
Right, where they miraculously made it home.
Yeah. But okay, let's unpack this for a second. Eugene Cernan leaves the lunar surface on December 14th, 1972 during Apollo 17.
The last man on the moon.
And then the stadium moon. The stadium just empties, the lights turn off. If the moon was so incredibly important, why did we treat it like some tourist destination we'd already crossed off our bucket list?
Well, the lights turned off because that first race had a definitive, undeniable finish line. The goal was beating the Soviets to the dust.
So once the U.S. unambiguously won?
Exactly. Once the United States proved it could reliably shuttle humans there and back, and the Soviet Union's competing N-1 rocket program literally exploded.
Wait, it exploded?
Yeah, their rocket was this plumbing nightmare of like 30 separate engines. It just kept shaking itself to pieces, so they pivoted to space stations instead. Yeah, so the core incentive just collapsed. The political will to spend billions vanished overnight because the point had been made. The first race ended because someone won.
But the second race, the one we were watching today in 2026, is entirely different.
Completely different. There is no single finish line this time.
Right, there's no trophy waiting at the end.
And that completely changes the paradigm. We are moving from a race of exploration to a race of extraction.
Okay, yeah. So if the Apollo era was about planting a flag to prove dominance, this new Artemis era is fundamentally about real estate.
Yes, real estate and resource.
Right, so think of Earth's gravity like a massive, invisible, 4,000-mile deep well. Right now, every single time we go to space, we have to carry all of our own water, oxygen, and fuel on our backs.
While climbing out of that well,
Okay.
which costs tens of thousands of dollars per kilogram.
Exactly. But if you can manufacture your rocket fuel on the moon, where gravity is just 1/6 of Earth's, it is like having a fully stocked supply depot sitting right at the top of the well.
The energy economics of the entire solar system flip overnight.
The moon essentially becomes a cosmic gas station.
And that gravity well concept is exactly why water ice is the single biggest material driver changing the game right now.
Because for decades, we thought the moon was just bone dry, right?
Right. But thanks to probes like India's Chandrayaan-1 and specifically NASA's LCROSS mission, we now know otherwise.
Oh, the LCROSS mission was wild.
It really was. NASA basically used a heavy piece of the LCROSS spacecraft as a kinetic missile.
They deliberately crashed it into a permanently shadowed crater at the lunar South Pole.
At like 5,600 miles per hour. And then they flew a second spacecraft right through the debris plume to sniff the dust.
And they proved unequivocally that there are millions of tons of water ice hidden in those dark craters.
Yes, and water in space is liquid gold. I mean, you can drink it, obviously.
But more importantly, if you run an electrical current through it, a process called electrolysis, you break it down into liquid hydrogen and liquid oxygen.
Right, you literally get rocket propellant and breathable air.
It's incredible. And then there's also the prospect of helium-3, right?
Oh yeah, helium-3 is fascinating. It's an isotope, meaning an atom with a different number of neutrons, that is incredibly rare on Earth.
But theorized to be abundant in the lunar topsoil.
Exactly, deposited there by billions of years of solar wind. It is considered the holy grail fuel for future nuclear fusion reactors.
Because it could theoretically produce massive amounts of energy without generating dangerous radioactive waste.
Right. Now, caveat here, we don't even have practical net positive fusion reactors on Earth yet, so it's highly speculative.
Sure.
But whether helium-3 extraction is economically viable this decade or not, the mere prospect of securing it is actively driving Chinese state planning right now.
But here is the massive catch with all these resources. They aren't just spread out evenly across the moon.
No, not at all.
The ice is trapped in the freezing depths of specific craters at the South Pole, places where the sun never shines and temperatures drop to like minus 300 degrees.
Right. But to run your mining equipment and crack the water into fuel, you need massive amounts of continuous power.
Which means you need sunlight for your solar panels.
Exactly, meaning you have to park your entire multi-billion-dollar base on the highly elevated rim of the crater where there is near constant sunlight.
And then send your autonomous miners down into the pitch black.
Yeah. And the South Pole is an incredibly hostile place to try and land.
I mean, landing at the lunar equator, like Apollo did, that's like landing on a flat parking lot in broad daylight.
Totally. The South Pole has the sun constantly at the horizon, so it casts these massive pitch-black shadows that stretch for miles.
So if your lander's robotic sensor mistakes a deep shadow for a flat surface,
you crash straight into the side of a jagged ridge. So, places that offer both continuous sunlight and safe access to ice, like the rim of Shackleton Crater, are incredibly rare.
So what does this all mean?
It means we are looking at a literal land rush for the most strategic real estate in the solar system.
Because whoever manages to navigate those shadows, touch down safely, and set up operating hardware, first creates a de facto claim to that territory.
Right. If your habitat is sitting on the only sunny ridge next to the ice, nobody else can land near you without risking a debris collision.
Physical presence becomes the law of the land, regardless of what any treaty says.
Exactly.
Knowing that the stakes are this high naturally leads us to ask who is actually risking the capital to get there.
And this isn't just a list of countries. We're watching wildly different strategies collide.
Yeah, let's start with the United States and NASA's Artemis program, because it represents a massive paradigm shift.
It really does. I flew an uncrewed capsule around the moon in 2022.
And Artemis II just launched successfully a few months ago, right? April 1st, 2026, sending 4 astronauts on a lunar flyby.
Right, but the actual surface landings are facing severe structural and scheduling hurdles.
Yeah, Artemis III, which was supposed to be the historic return to the surface, was restructured into an orbital test for 2027.
And the crewed landing has been pushed to Artemis IV in 2028, and even that is looking pretty shaky.
Okay, wait, I have to stop you there and push back on something. You're laying out the US delays, but we really need to look at why those delays are happening. NASA isn't building the lander this time.
No, they aren't.
They're completely outsourcing it to private companies. They've contracted SpaceX's Starship and Blue Origin's Blue Moon to ferry the astronauts down to the surface.
Right.
And a NASA Office of Inspector General report in early 2026 explicitly flagged huge schedule risks. I mean, Starship is an unproven, massive, wildly complex vehicle that requires refueling in Earth orbit before it can even go to the moon.
It's incredibly ambitious.
Right. Meanwhile, China is doing a purely integrated, state-run approach. They own every single nut and bolt of their hardware. Are we essentially watching a massive geopolitical gamble on commercial industry versus state patience?
That is the defining structural difference of the modern era. 2 roads to the same crater rim.
One built on commercial speed and contracts, the other on methodical state patience.
Exactly. I mean, it looks incredibly risky on paper, I'll grant you that. Relying on commercial partners who blow up prototypes as part of their testing process.
Which SpaceX does a lot.
Right, it's terrifying to traditional aerospace planners. But you are discounting the raw speed of commercial iteration.
Fair point.
Yes, the US is making a massive public-private gamble, but that commercial model allows for rapid failure and redesign that a traditional bureaucracy just can't match.
Even so, the contrast with China is staggering. China is meticulously building the International Lunar Research Station, or ILRS, targeting the 2030s.
And their robotic track record is flawless right now.
Flawless and highly strategic.
Absolutely. Think about it. In 2019, China's Chang'e 4 became the first spacecraft to land on the lunar far side.
Which isn't just about picking a new spot. Because the mass of the moon blocks all radio signals, you literally cannot communicate with a lander there.
Right. To even attempt Chang'e 4, China first had to invent and park a spiralized relay satellite called Queqiao in a halo orbit far beyond the moon.
Just to bounce the remote control signals around the moon and back to Earth.
That is apex engineering. And they followed that up with Chang'e 5 returning samples in 2020.
And then Chang'e 6 making history in mid-2024 by returning the first ever samples from the far side.
And now, Chang'e 7 is prepping for a late 2026 launch specifically to hunt for ice at the South Pole. They've merged their robotic and crewed programs into one streamlined, state-controlled machine.
Their Long March 10 rocket, Mengzhu capsule, and Lanyu lander are all fully in testing. But while the US and China are throwing billions at the problem, we have to talk about the ultimate disruptor in this race, India.
Oh, absolutely. The Indian Space Research Organization, ISRO, proves that you do not need a massive, bloated budget to claim a seat at the table.
They are the ultimate budget optimizer. Their approach to frugal engineering is remarkable.
It really is. Instead of building massive rockets, they use highly calculated orbital mechanics, using Earth's gravity to slowly slingshot their probes outward.
Just to save on fuel costs.
Exactly. Now, in 2019, their Chandrayaan II lander did crash into the moon.
But instead of retreating or losing funding, they just patiently fixed the problem.
Right. They treated it as a harsh engineering diagnostic, redesigned the sensors, updated the software, and then absolutely nailed the Chandrayaan III South Pole landing in August 2023.
And now they are prepping their Gaganyaan program for human spaceflight, targeting their own crewed lunar landing by 2040.
Yeah. And then you compare India's success with the tragic irony of Russia.
Oh man, Russia, the original pioneers.
Right. The nation that started the space race, the nation that panicked the US with Sputnik. They tried to beat India to the South Pole with Luna 25 in August 2023.
And it crashed just days before India touched down safely.
Exactly. Now they're strangled by sanctions and a huge brain drain in their aerospace sector. Russia is basically being forced to lean heavily on China as a junior partner for their lunar future.
We also see the wider coalition involved. The European Space Agency is deeply embedded, building the critical life support service modules for NASA's Orion capsule.
And Japan executed a stunningly precise pinpoint landing with their SLIM spacecraft in early 2024.
Proving that navigation software is getting incredibly sophisticated.
Exactly.
So let's look at the board here. If you have multiple heavily armed, technologically advanced superpowers rushing toward the exact same icy craters with totally different operational philosophies,
Right.
what happens when they bump into each other in the dark? Who is directing traffic?
Well, that is where we hit the legal vacuum.
Ah, yes.
The foundational document of space law is the 1967 Outer Space Treaty.
Right.
Now, it was drafted at the height of the Cold War, and its primary concern was pretty much just preventing Armageddon.
It explicitly bans placing nuclear weapons in space.
And it forbids any single nation from claiming territorial sovereignty over a celestial body. It actually calls space the province of all mankind.
Which sounds incredibly noble.
Noble, but operationally useless for what is actually happening today.
Right.
The treaty says you cannot plant a flag and claim you own the moon, but it is glaringly silent on whether you can extract and sell lunar ice.
It doesn't say whether a private company or a state enterprise can scoop up a ton of water, process it into hydrogen, and sell it.
Exactly. And because of that glaring loophole, we now have two competing coalitions trying to write the rules of the road on the fly.
So the United States is leading the Artemis Accords. It's basically a set of bilateral agreements with allied nations focusing on transparency, interoperability,
and crucially, the establishment of safety zones around lunar operations to prevent harmful interference.
Well, on the other side, China and Russia are leading the International Lunar Research Station's state partnership model.
Right. Both sides are deeply suspicious of the other.
Yeah, I mean, critics of the Artemis Accords view the U.S. safety zones as a backdoor to territorial control, because if nobody else can enter your zone, you've effectively claimed sovereignty over that land.
Right. Meanwhile, the ILRS is viewed by Western analysts as an attempt to build an entirely separate, opposing geopolitical bloc.
Neither framework is binding international law.
No. They exist in a gray area defined by diplomatic leverage rather than enforceable courts.
And here's where it gets really interesting. The subtext. The elephant in the room that nobody really likes to talk about.
Oh, the dual-use reality.
Exactly, because a rocket that has the precision to autonomously navigate shadows and land softly on a specific jagged lunar crater is a rocket that can also be used to intercept a satellite in Earth orbit.
What's fascinating here is that the dual-use reality of orbital mechanics just cannot be overstated. The physics of matching velocity with a lunar space station to dock a supply ship is the exact same engineering required to match velocity with a highly classified communication satellite to inspect it, blind it, or destroy it.
It's the same tech.
It is inherently military adjacent. This land rush isn't just about collecting interesting rocks or doing science.
No.
It is about military adjacent influence over the ultimate high ground. The nation that dictates the supply chains and navigation networks at the lunar South Pole will have an outsized influence over the security environment of Earth orbit.
So the science feeds the economics feed the geopolitics, and the geopolitics feed the military security apparatus. It's an unbroken chain. We are transitioning permanently from the Apollo era of planting flags and leaving to the Artemis and ILRS era of building landing pads, solar arrays, and actual habitats.
We aren't visiting anymore. We are building infrastructure.
Yeah. As you process all of this, you really have to resist two very common extremes.
Right. The first is breathless alarmism. You know, the idea that whichever nation drops a lander on the South Pole next week is going to magically dominate the global order forever.
The logistics of surviving minus 300-degree nights are simply too punishing for that kind of instant monopoly. This is real science, real geopolitical signaling, and real economic calculation, all feeding into each other.
It's the ultimate high-stakes gamble.
It really is. And that leaves us with a final thought for you to mull over. Our sources make it abundantly clear that every single major program views the moon not as the final destination, but as a stepping stone to Mars.
Right.
The moon is destined to become humanity's first fully functional off-world supply chain and manufacturing hub. It will process its own water, refine its own fuel, and build its own materials.
Out of lunar dust.
Exactly. So how long will it be until this lunar economy becomes completely self-sufficient?
That is the big question.
Right. Imagine a day when the infrastructure on the moon no longer needs resupply from Earth at all. In building this cosmic gas station, we might be birthing the first truly independent off-world civilization.
A civilization that eventually dictates its own rules.
Completely untethered from the politicians, the budgets, and the treaties 238,000 miles below.
It really makes you view the night sky in a completely different way, doesn't it?
It really does. So the next time you look up at the moon, don't just see a museum of bleached flags and preserved footprints. See the active construction site of humanity's next era.